Hey everyone. All right, here we go. Section 8.5. Okay, continuing on with our rational expressions. Again, a rational expression is just a fraction. So today we are going to be adding and subtracting fractions. Okay, and so let's look at the simplest kind of adding and subtracting that we've learned since you were in elementary school. Okay, something like, let's say we had 1/2 plus 3/4. Okay, so something simple like this. Hopefully you remember you would need a lowest common denominator. Okay, your lowest common denominator here would be 4. Okay, lowest common denominator, you have to think it's actually the least common multiple of denominators. Multiple meaning multiply. So if I look at 2, right, it's not a common denominator, but multiples of 2 are 4, and 4 is common with 4, okay? So we have our lowest common denominator, 4. And then what we do, since our lowest common denominator is 4, is I look at, okay, say 1/2. Now, to make 2 a 4, I need to multiply it times 2, and I have to do it to the top and the bottom because that's multiplying by a fraction of 1. 2 over 2 is 1. So I multiply top and bottom, so over here I get 2/4. And then this one's already has the common denominator of 4, so I don't change it, 3/4. And now that we have a common denominator, we can add the numerator. 2 plus 3 is going to be 5/4. And we're done. If we could simplify that fraction, we would, but there's no need to because we can't. Okay? And so that's very similar to what we're going to be doing today. Okay? Of course, there's going to be variables. It's going to be a little bit more difficult. So before we get into adding and subtracting the fractions, I do want to talk about the least common multiple. Okay, we're talking about multiples here. So we're looking at the got it choice D. This is the only one I'm going to do. We're going to keep this problems very simple, so we're not going to do a lot of these problems, okay? So the got it choice D. If we're saying 12x squared y and 4xy, if those were the denominators of two separate fractions, what would the lowest common denominator look like? So we're looking for the least common multiple for these two. So between 4 and 12, okay, think of multiples of 4, okay, because 12 is not going to go into 4, okay? Multiples of other 4 are 8, 12 not going to go 8, and then multiples of 4 again, 12. So 12 does go into 12. So multiples of 4 that work with 12 are going to be 12. And then the x squared and the x here, okay, these are also, like, I guess your like terms, so you want to get the common term out of that. And it's always going to be the highest exponent. So in this case, x squared. Okay, you always want the bigger one. And then between y and y, you can see that they're both a y to the first and both a y to the first, so they're already a common. Y to the first is already common. And so this is your least common multiple. If this was fractions, this would be your lowest common denominator between the two. And that's going to be a little bit on the harder side of what we're going to look at today, okay? So let's start with we're going to add and subtract, but we're going to look at fractions that have already a common denominator. So that's what I'm saying. We're only going to do a few problems. Most of them will have a common denominator. We'll do one today that does not have a common denominator. We're going to keep it simple here. Okay, so this already have a common denominator of 3x. When it's a common denominator, all you need to do is add the numerator. Okay, so if I add 5 plus 4, I get 9. That's 9 divided by 3x. Now, it's always important to simplify your fractions, okay? So this brings us back to the last section where we're simplifying, and we're going to look at factors, okay? And so in this case, I do have 3 times x. Those are separate factors, and then I have a 9 on the top, and I see that 3 can go in 9 3 times. And so on the top, I am left with the 3, and on the bottom, I'm left with an x. We do not need to state our restrictions on these, okay? But do keep in mind that the restriction here is that x wouldn't be able to be 0 because that would give you a 0 in the denominator. But they are not asking us to state the restrictions. So we are done. 3 over x is the answer to our problem, okay? Let's look at another one. We're going to come down to the got it E, okay? And I'm actually going to change this problem a little bit. I want to change it to subtraction. So I'm going to white out the plus sign here, okay? I'm going to change that, and I'm going to make it a minus. Okay, so I want to make this subtraction. So please change that on your paper as well. Okay, we're changing it to subtraction. And this is important. I want to do this problem because a lot of people will subtract the 6x, but then they'll forget to subtract the negative 6 also. So my the easiest way to forget to do the to not do the subtraction to everything, okay, is to make sure you just rewrite the problem. So I'm going to rewrite this now. Watch. I'm going to rewrite it as 6 over x squared. Okay, and I'm going to distribute that negative, that minus to the 6x and negative 6, so that this becomes negative 6x and positive 6. Okay, let me rewrite that. And now you can add them together. Okay, so what I've done again is I've taken this negative basically. Come on. Why is it not? Oh, I know why it's not working. Okay. And I've distributed to the 6x and to the negative 6. Okay. And now it's just about combining the like terms. Okay. Your like terms here on the numerator are just going to be this 6 and this 6. And the reason why I can do that is the denominator is the same. It's x squared and x squared. And so that just goes to adding the top. Okay, we're adding the numerator. And so my numerator, I have a negative 6x, and then 6 plus 6 is 12 in the numerator, and that's all over x squared. Okay? You always want to make sure you can simplify these, okay? So right now it doesn't look like I can cancel anything, but always factor to make sure that you aren't missing anything. So on the top here, I can take out a greatest common factor. Okay, so I could take out a negative 6 on the top, and I'll be left with x minus 2, and that's over x squared. And now I have my factors here. It's negative 6 times x minus 2, and then it's over x squared. I still don't see anything to cancel, and so this is going to be my final answer. So sometimes you're going to factor a greatest common factor out or whatever, and you're going to see like, oh, it doesn't matter. I can't cancel anything. This was simplest form, and that's okay. All right, so the big takeaway here is if you have a minus, make sure you subtract everything. So I subtracted the 6x, and then I subtracted a negative 6, which makes it a positive 6. And then it's about combining your like terms because you have a common denominator already. Please keep in mind that it is possible, if this was a multiple choice test, it is possible that your answer could either look like this one or it could look like this one, but you need to know how to go back and forth between both of them. Obviously, they're both the same exact answer, so it's possible that you could see one versus the other, okay? So just be aware that if you don't see negative 6x plus 12, it's because maybe it's factored to negative 6 parentheses x minus 2, okay, or vice versa. All right, so make sure you do understand that you might need to go switch between the factored or non-factored form, okay? And again, that is with like common denominators, okay? And so now we're going to come back up here and we're going to do B, and this one does not have a common denominator, okay? One has an X and one has a Y. When it's a common denominator or an uncommon denominator and you're looking for the lowest common denominator, you're going to take all the factors possible. So right now I have a factor of X and I'm going to have a factor of Y and I'm going to multiply them, okay? And that's going to be my common denominator, the X and the y. You need to multiply them. And then for each fraction, what you're going to do is 3y over x. I see that in order to get my common denominator, I need to multiply the top and bottom by y. And then for 4 over y, I see I need to multiply by x over x. Okay? Because what happens now on the top, or on the first fraction, I have 3y squared over x times y. And on the second fraction, I have 4x over x times y. And now they're both over a common denominator of xy. So again, the lowest common denominator was x times y because I need both of those factors in my denominator. okay? And then you are just multiplying each fraction by what is missing. So the first fraction was missing a y, so I multiplied by y over y. In the second fraction, we were missing the x for the denominator, so I multiplied by x over x. And now we have this common denominator, x times y and x times y. That allows us to add the numerator together. So 3y squared plus 4x is just 3y squared plus 4x. There's nothing else I can do with that. And that's over your common denominator, xy. I can't factor this. There's no more simplifying involved. And that is my final answer. Okay? So a little bit more complicated because you do have to find the common denominator. But once you multiply both fractions to get a common denominator, it's just like this example A or the got it, where you're just combining the numerator. Okay. And that's all we're going to say about those problems. You can see that example C, D, and F are a lot more complicated, okay? We're not going to get into complicated ones like that in the homework or anything, so our examples are good there. The last part we're going to do is on the second page, okay? And we are going to simplify these complex fractions, okay? If you think of a complex fraction, I'm just going to use numbers now. Let's say 1/2 divided by 3/4. These are called complex fractions because they have a fraction inside of a fraction. That's why it's complex fraction, okay? They are division, right? So I could rewrite this as 1/2 divided by 3/4. And if you remember that when we divide two fractions, what we're actually doing is multiplying by this reciprocal. Okay, so we're multiplying by the reciprocal here. Okay, and so this becomes 1/2 times 4/3, which we can simplify by you can do the simplifying before you do the multiplication. 2 goes into 4 2 times, okay? And then on the top it's 1 times 2 is 2, and on the bottom it's 2/3, okay? And that would be the answer there. And so that's all we're going to be doing. In a complex fraction, we're dividing by two fractions, and so we multiply by the reciprocal, okay? But now we're going to add variables. So on this one, okay, we're dividing by two fractions. It's always the bottom one. You take it and you're going to multiply by the reciprocal here. Okay, so the reciprocal would be m over n. And so I'm going to multiply the top by m over n. Okay. If there's nothing to simplify, you would just multiply straight across. So I multiply across here, multiply across here. 1 times m is m. Ooh, m. And then on the bottom, n times n is n squared, and we are done. I can't simplify that anymore because one is an m and one is an n, so it's done. Okay. Let's go to B, same idea. Okay, when we divide two fractions, we multiply by the reciprocal. Okay, so I'm going to take y over x and I'm going to multiply it by x over y. It's always the denominator that gets flipped. Okay. If you can, reduce in the beginning. If you forget to simplify in the beginning, like cross cancel, okay, you can simplify in the end. That's not a big deal. But I like to simplify in the beginning so it becomes less complicated. So I see an x divided by x is 1, and that's all I can simplify. On the top I have 3, and on the bottom I have 5 times y, which is just 5y, and my answer is complete. Okay. And then the last one, the got it. Okay, again, we divide fractions, so we multiply by the bottom one, we multiply by the reciprocal. So 4 over x is going to become x over 4. We multiply the numerator by it. I like to simplify in the beginning. So x divided by x cancels to 1. So you can cross cancel or you can reduce top to bottom. Okay. And then my final answer, I have a 5 on the top, and then it looks like 4 times 4 is just 16, and then I have 5/16 as my answer. And those are complex fractions. Okay, complex fractions, fractions inside of fractions, and we multiply by the reciprocal. That's how we do it. And that's the end of our section, okay? Again, we're just keeping it simple. We're not in a classroom, so we're just trying to keep it as simple as possible. You have an assignment for section 8.5. Go ahead and complete the textbook assignment and Dropbox that assignment to School Loop when you're done. Have a great day, everyone.